We've introduced a really crucial debate in cognitive science between the respective roles of images and sentence-like propositions in thought. There's a lot more to thought than that, and that oversimplifies things. You know about a lot of different kinds of things. You can reason about a lot of different domains. You know about music, cognitive science, mathematics, your family, cooking. You know all kinds of things. And that knowledge must be somehow organized. And if we regard knowledge as residing in representations, then the manner in which it's represented will really, really matter. And we can show this in quite a direct way. So, for example, numbers. You might think numbers are just numbers are just numbers. But if you look at the bottom here, there's a sum in numbers. On the left-hand side, you see 3,456 plus 284. That's a sum. It's tedious, but you could do it. It's very easy. You learned how to manipulate these. Those kinds of numbers are called Arabic numbers because we got them from the Arabic cultures. On the right-hand side, you see the exact same numbers represented in the fashion that the Romans used to represent them, using Roman numerals. Now, Roman numerals were great for carving into stone because they were very simple. It's quite difficult to do a curly 6 and a 5, but these straight lines, they have some curves like the sea, but they're great for carving. But boy howdy are they rotten for arithmetic. Calculating using Roman numerals is an absolute disaster. So the numbers are the same. That is, the thing represented in each case is the same. The form of representation, on the left-hand side using a place-based base 10 Arabic numeral form of representation, makes computation really easy. The right-hand side using the Roman system, which is based on a mixture of base 2 and base 5, by the way. It's really complicated. And it looks arbitrary to our eyes, and it's horrendous for doing computation. So the manner in which you represent something doesn't only speak to the relationship between the thing represented and the thing that represents it. It speaks to the ease with which you can do things with it. So some representations will support some kinds of operations, and different form of representation might make those kinds of operations harder. We're going to look at 5 examples of this. Here's the first one. I hope you remember what a phone book looked like. They've kind of gone out of fashion. Phone book was a big tome that was delivered to the door once a year, absolutely full of all the phone numbers. Well, there got to be so many they couldn't do the whole country, and so you had a Dublin phone book. You had 4 or 5 phone books for the whole of Ireland. I hope you've seen one. If you have, then you will know how to address this challenge. If I give you the phone book and I say, please look up the number of Mr. Thelonious Winterbottom, you would know what to do. Here's a big phone book. Open it towards the back. Find W, WI. They're alphabetical. The names are stored in alphabetical order based on surname. And it would not take you long to find Thelonious Winterbottom's number. So that information is represented in the phone book and is easy to find. Now, if you have the same phone book and I say, who owns this phone number? That information is presumably also in the phone book. But how do you find a phone number in a phone book if you don't have the name? The association between name and number is still there, but the phone book is organized in alphabetical order by name, not in numerical order. On a computer, you can shift between these different kinds. That's one reason computers are so powerful, is that they can re-represent. But in a physical phone book, your only option here is to start at the first entry, check it, is it that number? No, move to the second entry, and it's going to take you forever, and you might miss it, and it's absolutely horrendous. So the phone book supports lookup by name. It does not support lookup by number, even though the phone book simply consists of name-number pairs. So you can see that the manner in which those associations are stored in the phone book greatly affects what you can do with it. So now let's probe your knowledge of the musical domain. Suppose Supposing I give you this. Name 3 bands who are a bit like the Beatles. I'm not going to suggest an answer to you. You can come up with any answer you like. I don't know who you think is like the Beatles. Maybe the Rolling Stones because they're also from the same era. Maybe Weezer because they sound a bit like them sometimes. I don't know. You could do this. I'm quite confident that you can come up with 3 bands who are a bit like the Beatles based on, I don't know, era, impact, sound, popularity. I'm sure you can do this. Name 3 bands where the 4th letter in their name is U. You got to think a different way for this one, don't you? When I said Beatles, you've heard of the Beatles. And so you start thinking about other bands. And something pops up. I said the Rolling Stones. They sort of come to mind. If I ask you about the 4th letter in the name being U, no. How do you even begin to answer that? What do you think of a band? Nirvana, N-I-R-V. Nope. Beatles, B-E-A-T. Nope. And here we are. It's like searching the phone book for a number. The knowledge is in there. If you come upon a band where the 4th letter is U, then you go, yeah, that's a match. But you've no way of, as it were, searching your phone book in the head. So you know about bands and their names and how to spell their names, but that knowledge is not organized in a way that allows you to do this with it. Whereas questions of similarity in style and popularity and so on are easy to answer. So the first 2 were about phone books, second 2 were about bands. That's not the kind of thing cognitive scientists ask about a whole lot. But what about this one? Name 3 words that rhyme with flap. Slap, clap, trap. There you go. That was easy. That was so easy. It's so easy that it's really important that it's so easy because it tells us that, there's many ways our knowledge of words could be organized. Imagine if they were all stored in your brain alphabetically. They're not. What this shows you that question is so easy to organize, it tells you that rhyme is really important in words, and your vast knowledge of language includes a role for rhyme. And if you're investigating the sounds of words, that simple question alone tells you that rhyme is going to be supremely important to look at, and it turns out it is. Phonologists are well aware of this. So those 5 little challenges tell us something. In challenge 1 and 2, they tell us that the information in a phone book is organized that supports some tasks and makes others desperately difficult, even though they're still theoretically possible. Challenges 3, 4, and 5 tell you something about how your knowledge is represented. Your knowledge about bands in the first 2 instances, and your knowledge about English phonology in the last one. So by coming up with well-designed questions like this, one can probe in a rather abstract fashion the organization of knowledge. Now, we're not committed to any specific theory about brains here, but you can see that we are gaining knowledge about the underlying structures that allow you to answer questions about stuff that you ostensibly know. So that's hopefully interesting.